So we're back again with Ryan Snell, our software development manager here at RunSignup. And today we're going to be talking about some of the photo platform updates that you made. First of all, what is an object request? Because Kevin and I were trying to figure this out, and we're not quite sure we got it right. And I don't know what an object request is, so we'd have to ask the developer about that, but we had a lot of those. Can you hand me that remote? Object request. That was good.
So an object request is anytime a resource, like an object in S3, is requested. And I realize that that's basically paraphrasing what you just asked me. So an object would be, in the context of photos, it would be all the different sizes of an image. So when you actually upload an image, we do multiple things with that. We take the image, we save the actual raw image that you uploaded, and then we do various optimizations, resizing of that image. Let's say you had a 15 megabyte photo. We don't actually want to have that 15 megabyte file sitting on the page every time someone goes to look at their photos, because that would make it take excessively long and it would just be consuming data for no good reason. So what we do is we resize it to different sizes. We have thumbnail, large, etc. All those are different objects that are stored in AWS. And for those that don't know, AWS is Amazon Web Services, and that's our cloud hosting provider that we use here at RunSignup. It's basically any time that object gets requested. And so that could be from your browser. So let's say you go and look at a results page and maybe it has some photos of you. We're actually counting those thumbnails in that number. So like all those times that we're looking at the thumbnail, getting the large, downloading the original, and the various types of requests that we have for usage in the platform. So for instance, we have the watermarking capability. The system will actually do some requests itself to be able to generate that image, because it actually has to download the original image, watermark it, save it, and then you request the new one. So even a simple request like that might yield a handful of object requests. So that's why that number is pretty big.
Cool. Now, do you want to talk about some of the infrastructure improvements you made?
Yeah, absolutely. So we like to always try to refresh some of our infrastructure. Photo platform, we've had it around since 2016. And we always try and make sure that it stays up to date with the latest security patches and whatnot. And so we kind of did a little bit of a mini project over the past couple of months to clean up some things in there, because we've had the system around for a while. So one of the things I'm excited about is the accelerated upload endpoint. So what we have with the photo platform, it's kind of unique, because when you go to upload photos, those photos actually are not traversing through our servers. So we have a serverless setup for our photo infrastructure that allows us to scale it as necessary, because we don't actually have fixed servers that are running to handle it. We kind of outsource that to Amazon, and they're able to scale up their infrastructure to meet our demands. So what happens is when you go to upload your photo, it goes directly to S3. S3 is Amazon's simple storage service. That's why it's called S3, because there's 3 S's. And that's what's used for a lot of storage of files within Amazon's infrastructure. We use that for storing the various photos in different sizes and whatnot. So the accelerated endpoint, the really nice thing with that is previously what we were doing is when you go to upload, it would go always to the US East 1 region of Amazon. And that's in Virginia. So up here in New Jersey, we probably wouldn't notice that much of a difference, because New Jersey is not that far from Virginia. And those photos actually do go across multiple wires all the way down to Virginia through different data centers. The accelerated endpoint, what that does is it utilizes various edge cache locations, and it uses those to route the traffic. So if you're in, let's say, Oregon, and you're uploading your photos, previously would have to hop around to different data centers to get all the way from the West Coast to the East Coast. Now what happens is your browser will pick the right one, and it will go to a different, let's say, data center, maybe out in Portland or something like that. And it will go from there to the West Coast. And then Amazon and various data centers have a lot better ways to handle traffic when going from data center to data center. So the upload performance could be, double or even triple in terms of speed compared to what it used to be, especially if you're on the West Coast now.
So the race director would go in, or the photographer or the timer, whoever took the photos, and they would upload those photos, and then they would go to whatever server is closest to them.
Yeah, this all happens in the background. So previously it would be a fixed endpoint. It would always be Virginia, let's say. Now it's dynamic, so the region's not in there. And so I can get detailed if you want. It goes through a DNS request to go figure out what the correct server it should be, and then it comes back with the appropriate one. Probably one that's within 100 miles if they're in a major metro area or so. If not, it would be the nearest city probably.
So then once the photos are on there, if someone comes and views the page...
Those are still from Virginia, but uploads are the pain point, I would imagine, for a lot of people that are interacting with our photo platform, because the uploads are from high resolution cameras and they can go all the way up to 15 or even higher megabytes. We recommend 5 megabytes if you can, because that's probably a lot smaller. We don't really usually need that much, but our system can handle photos that are bigger. And if you have the upload speeds to support it, we can support files that are bigger than 5 megabytes though.
Okay, so the reason why it goes to somewhere closer on the upload is so it's not going all the way across the US.
It still reaches the same destination, but the point is how you get there. The analogy would be if you were to go, let's say, a cross-country trip and you decided to use the Avoid Highways button on Google Maps. That will make it take a lot longer, or you can use the highways, and that's kind of a different way of thinking about it. It's just a matter of how fast it can get all the way out to the right location. So it can take a much more efficient route when it's being routed from, that cache location, because Amazon controls everything in there. If we didn't use that, then your internet service provider, depends on who they're contracting with for their traffic and how it gets all across the wire all the way back to Virginia, right?
Okay.
They have more control over it, I guess, is one way of thinking about it. So they can route the traffic and optimize it as such.
So what other kind of updates have been done?
So other updates that we did were updating our uploader. One of the things I noticed when I was in there was your browser is actually kind of resizing files, the photos themselves, nothing on your computer, but in memory it was doing some unnecessary optimization that we weren't even taking advantage of. So I kind of set a different parameter in one of the libraries that we're using for that to not do that, and that should yield a lot better performance, especially if you're uploading, let's say, 1,000 high resolution photos at a time.
So what kind of optimizations was it doing?
So it's our upload library, and it had a feature to show a thumbnail basically in the uploader. We had actually taken that thumbnail out several years ago, but the code to actually take the full-size image and resize it in your browser to be able to render that thumbnail, that optimization, that resizing and whatnot was actually still taking place. So it was just unnecessary computations that your computer was doing that really no one was taking any advantage of, or there was really no benefit to it at all. So simple one-line update to that file, and things should be a lot smoother for people.
And I see we've got some upgrades to the tagging.
Yeah, so we also upgraded our tagging engine. So after you upload a photo, the photo goes through various different things. I think we already talked about what happens when you upload it in terms of how it gets to Amazon. After it gets to Amazon, it kind of takes on a life cycle of different things. So the first thing that happens is it kicks off a process, and this happens for each photo. So if you upload 1,000 of them, 1,000 of these things will happen. For each photo, it goes, and the first thing what we do is we capture the metadata in there, and we generate a thumbnail for it. That's kind of the origin of what happens. And once we have that, we basically have enough to put it in our database to be able to know what's going on with that image, because we know what race it's for, what event it's for, what type of image it is in terms of, like, let's say the file name. We don't really use that, but we capture some of that stuff just in case in terms of being able to sort. And then also the thumbnail, so we can actually render it. And we have the original, so we're able to do stuff with that. After the original is generated, we also go and do more things. We generate the large version of that. The large version of the image is what happens when you click on the image, because we don't want to show the original image because that's pretty big. And unless someone specifically requests the original, we like to show one that's a little bit smaller. So I think it's about like 900 pixels or so. That after that large one is generated, we also generate other sizes, Like we have a different size that we use for tagging. Once we have that one established, that one's a little bit higher resolution, about 2,000 pixels or so. That goes to our tagging engine. Previously, we had to take a look at what events were in the race to be able to pick the appropriate engine for that, because we had two different engines, one for race and then one for biking. Now it's just the same engine. It's kind of able to do both. So if you have an event that has, let's say, a running component and a different event that's just biking, the system can pick up on that a lot better because we don't have to arbitrarily pick which engine to use. It will tag them both. And so then that kicks off. And that can take a few minutes sometimes, especially if it's backed up. After we get the result from that, that goes back into our database. And then we're able to kind of tie the photo to the bib numbers. From the bib numbers, we're able to tie that to the results. And that's kind of how we make it all work. So that way, if you search for your last name, you find your result. And if there was a photo of you, it's kind of magically there. And the idea behind that is the race director doesn't have to go in and tag things manually because the system is already doing that by itself. And it's pretty complex because it's trained on things like partial reads. So let's say your hand was covering part of the digit. If you have enough of that image and it knows the right type of typeface and it's trained on the right type of data, sometimes it can actually fill in what's missing. We're able to do that as humans, but sometimes computers struggle with that. And as different types of learning models for computers keep increasing in terms of what they're able to do, we're able to take advantage of that. So it's just one of the nice things that we offer for free as part of the photo platform.
So how was tagging different for a bike race as opposed to a running race?
So we only used the biking engine when we knew that all the events within the race were biking events, and that's set up in the race wizard. Other than that, I would always use the running one. So if someone had a race that had different types of events, it might have not been so great because it might have been using the wrong engine. It's not trained on the right data sets. Therefore, you might not have any tags at all, even though you should have had them. So now, if you have a race that has a mix of different type of event types, it should work a lot better. It's just a matter of how the model is trained and what kind of data set it's trained on. So now it's being trained on the different types all together at the same time.
And when the participant goes in and downloads whatever photo they want, do they get the original or the large?
So when you click on it, what shows up in your browser is the large. And then if you click on that little download button with the arrow that points down, that usually should download the original. And if the race had watermarking set up, it would be the watermark version of the original.
All right. And then I see one more thing on the list there.
Yeah, so we actually have quite a number of photos. So one of the things I noticed when I was in there poking around was we have, I think it's over 67 terabytes of photo data stored. So I know storage is getting cheaper, but we don't store them on little portable hard drives that you get from Best Buy here. They actually go out to Amazon. And there's a lot of stuff that Amazon does to make sure that those files stay there and are backed up appropriately. But there's things that we can do to kind of lower our costs to be able to continue to offer this service for free. Amazon has different mechanisms of storage in terms of how they have different tiering levels in terms of their access frequency. So, for instance, they have something called Glacier, which after, let's say, a file is sitting there for a while, you can move it into Glacier. Now, that's kind of more ice cold, as Glacier might make you think. So that we don't use because, you could say, I want my photo, and it might take like a day for you to get it. So we can't do that. But they do have a different level that we're able to take advantage of that might be slightly slower, but no one really ever should notice that much of a difference because we're not using it for anything that needs to be real time. Like we don't have, things like financial stuff for like a stock market running through it. So we don't need to always take advantage of the most performant option. We can kind of trim it back a little bit and take advantage of some of the cost savings with that.
All right. Well, thanks, Ryan.
Always fun chatting with you, Andrew.
What are you working on next?
It's always a good question.
Find out. Keep watching, people. Subscribe.
Hit that like button.
Yeah. End on a cliffhanger. That's how we get them coming back tomorrow.